Beautiful. Out of all the things that we did in this unit, I think this might be the most important thing. Have you guys seen BEDMAS before? Has anyone heard of that? Okay, good. So it should be a little bit of review, but we will go over it again because it is so vital, and it's something that you do in math like all the way through. And if you can't do BEDMAS, you pretty much can't do algebra, which makes it super hard to be successful at math later on. I'm going to use this acronym, BEDMAS, like this. Some people use the words PEDMAS. I use the word BEDMAS with a B instead of a P. The only difference is what you call brackets. So I call brackets brackets. The real actual name for them is parentheses. So sometimes people call it PEDMAS. If you've ever seen that, it's the exact same thing. Okay? I'm just using a different letter. What BEDMAS does is it tells us the order in which we should perform mathematical operations. When you're doing PEDMAS, there's a couple that actually partner up, and you can switch them back and forth. So for instance, the A and the S, which stand for addition and subtraction, you can do those in either order. You can do addition first or subtraction first, it doesn't matter. The other one that pairs up is D and M, which stands for division or multiplication. So when you're calculating numbers, you could switch division and multiplication back and forth, and you'd still be good. The E stands for doing your exponents. The B stands for doing brackets. You must follow the order in which BEDMAS arrives, except for the two that are packaged up. Okay? I'll show you kind of how this works. The easy way is to use BEDMAS. Let me just write that down.
Why don't you just buy one?
Because he got mad.
Awesome. BEDMAS. So we're just going to run through it. I always see these questions on Facebook. People are always like, oh, what's the answer to this question? And people always screw up BEDMAS as adults, and we all publicly shame each other for being bad at math. It's really nice. So hopefully by the end of today, you won't get publicly shamed like half of my adult friends. Yeah, what's up?
You know that thing on Facebook is like...
Okay, so this first question. If I'm reading this question, gentlemen, no. Reading this first question, this is 5 times 4 minus 12 divided by 2, right? Just looking at it, that's what it all says. If we wanted to calculate it, we're going to perform BEDMAS. BEDMAS means do anything inside brackets first. That's the first letter, B. There are no brackets in this first question. The second thing is to calculate any exponent second. That's the E in BEDMAS. There are no exponents in this question. The third letter is to do D, which is division. If there's any division symbols in this question, you should calculate that first. We do have division. We have a division right here. We have 12 divided by 2. That's the first thing you should calculate. Everything else is going to stay the same. So when I look over here, my 5 times 4 and my subtraction stay the exact same. In my calculator, I put 12 divided by 2 to get 6. So the only number I've changed is in red, and I'm showing you where it came from by underlining the red part. The fourth letter is M. M stands for multiply. If there's any multiplying in the question, you need to do that next. If I look here, I have 5 times 4. That's multiplication. I need to calculate that next. Everything else stays the same. So 5 times 4 is 20. My minus sign stays. My 6 stays. My next letter in BEDMAS is A for addition. There is no addition to do in this question. My final thing is S for subtraction. If you have anything that needs to be subtracted, subtract it. For us, we have 20 minus 6. That equals 14. And that's the answer to that question. The order does matter. So if you just did it in whatever order you wanted, I'll show you what you actually would have got. So if you put it in your calculator as an entire thing, and you just put 5 times 4 minus 12 divided by 2, your calculator will just go in order. So it would do 5 times 4 to get 20, and then it would do minus 12 divided by 2. Then it would do 20 divided by 12 or minus 12, and I get 8 divided by 2.
Yeah.
And then it would do the division, and it would say that the answer is 4. So did your calculator do it right? Yeah, some calculators will do it right, some will do it wrong. It'll also make a bigger difference once we start getting to fractions and bigger questions, because the fractions definitely screw it up. So if you were to just go left to right, it actually gets you the wrong answer. That's why BEDMAS exists, so that you know how to do it right every single time. We'll do a whole bunch of these together, just so you guys get the flow of it, and then that's when I'll give you your practice, so you should be able to finish the whole sheet today. So if you look at the second question, B, it says 8 plus 12 times 5 minus 2. If I need to calculate what that equals, I do BEDMAS. I do brackets for B. There are no brackets. I do exponents for E. There are no exponents. I do division for D. There is no division. I do multiplication for M. I do have multiplication. I have 12 times 5 right in the middle of that question. Everything else stays the same. So 12 times 5 is 60 in my calculator. Everything else stays the same. The next thing I do is addition. I do have some addition in my question. I have 8 plus 60, which would turn into 68. And the minus 2 is still there. The last step is S for subtraction. I do have a subtraction. 68 minus 2 equals 66. Awesome. I want to show you that we actually could have done the addition subtraction in any order we wanted and been fine. Because there's a couple things that you can change the order and it's okay. With BEDMAS, you can do subtraction before addition and you'll still get the same answer. And multiplication division can flip-flop as well. So those are the ones that can switch. Looking at this question, if I flip and I do subtraction first, that would give me 8 plus 58. 8 plus 58 equals 66. So we often say that addition and subtraction could be reordered or it could be done in any way you want. And that's kind of an important concept moving forward, that you could reorder addition and subtraction. You can go any way you want. Multiplication division, we don't see it quite as much. A little bit we do with multiplication, we will reorder it. Addition, subtraction, we reorder a lot. Awesome. Looking at C. If we're doing BEDMAS, we start with B. There's no brackets in this question. We do E for exponents. There's no exponents in that question. We do D for division. We do have a division symbol. It's right in the middle of the question. 8 divided by 4 would turn that middle number into 2. The other numbers remain the same. Yeah, so if you're looking at that, now you're down to just addition and subtraction because there is no M, right? There's no multiplication. So you could do the addition and subtraction however you want. If you visualize that, you can look at it and be like, negative 2 plus 2, 0, crosses out. You can definitely do that and get your answer of 16. If you want to do it step by step and you want to look at this and go 16 to minus 2 is 14 plus 2, and then pair up 14 plus 2 to get 16, that works as well. As long as you're doing addition and subtraction as your last two things. Yeah.
So it doesn't really matter.
It doesn't really matter. Addition, subtraction, flip-flop. I want you to try D and E on your own. We'll do F together because it's a little bit more confusing. So I'll give you a minute to try D and E, and then I will go through it. Okay, so if you want to see your answer. For D, you're running through BEDMAS. Brackets first, there are no brackets. Exponents next, there's no exponents. Division. If you look, we do have division here. We have 5 divided by 10. So we want to change that, and if you put in your calculator, it'll be 0.5. Everything else remains the same. That means the 8 stays the same, the multiplication stays the same, the -3 stays the same. After division in BEDMAS is M for multiplication, so I have to multiply anything I have in here. I do have multiplication. I have 8 times 0.5. That equals 4. Everything else stays the same. So that means the negative symbol or the subtraction and the 3 stay the same. And my final answer would be 4 minus 3, which equals 1. Again, you could reorder the division and the multiplication and get the right answer. So if you look at this question, it might be easier to do the multiplication first instead of the division first. So if I was doing this, 8 times 5 is 40. Everything else stays the same. Then I could do 40 divided by 10 is 4. And the -3 remains the same. And you notice you get to the same spot. You just did multiplication first, division second. So your D and your M can flip-flop. Just like your A and your S can flip-flop. The B and the E must stay in the order that they're in, though. Awesome. For E, if you guys did this one, BEDMAS, no brackets, no exponents. We do have division. So we have 12 divided by 6 is 2. Everything else stays the same. Then you can do addition, subtraction, whatever order you want. I would do 19 minus 9 equals 10. Then I would leave my plus 2. And 10 plus 2 is 12.
It's 8 though.
No, it's not. No.
Yeah, it is, bro.
How'd you get 8?
Okay, so first I went 12 divided by 6, right?
Yep, to get 2.
Equals 2, yeah. And then I went 9 plus 2, yeah. And then it equals 11. And then I went 19 minus 11, which equals 8.
That was trippy for a second there. I was freaking out. I was like, how did you do that? That was witchcraft. Okay, so what Drake was saying was he got to this point. 19 minus 9 plus 2. And he said he added 9 plus 2 to get 11.
Yeah.
Which is right, 9 plus 2 is 11. But this isn't a 9. This is -9. So if you're going to do the addition first, you would treat this subtraction 9 as a -9. And -9 plus 2 is -7. And then 19 minus 7 is 12.
Yeah.
That tripped me out, though. I was like, I've just relearned all my math from like when I was in grade 8 to now. That's a good point. Maybe we should just go left to right to keep it simple once we get to addition subtraction.
Yeah.
Because that was craziness. Yeah, that was craziness. So we're now going to abandon everything I've ever said. Left to right.
I'm smart.
Just when it comes to the addition subtraction stuff, we'll go left to right.
You just spoke to English.
I did. I was so confused. It took a while. I was so confused. All right. Whew. We should send you into other math classes and say that exact thing and see what the other teachers come up with. See if they get it right. All right. F. F is our first time that we're going to experience exponents and brackets. So if we're doing BEDMAS, which we are doing BEDMAS, I like to write it out for every question. B tells me to simplify anything inside brackets. If you look, we do have brackets, but there's nothing inside the brackets that needs to be done. Like the brackets are right here, and inside the brackets, it's just -2. So we just leave it alone. If there had been, say, something like 3 minus 2 inside the brackets, we would have calculated it. That's where we would have started. Second thing in BEDMAS, E for exponents. That means you need to simplify anything that has an exponent, and we do have 2 different exponents here, like 2 different powers. The first one is right here, -2 to the power of 4. It's been a little while since we've done exponents, but remember that the base has to be in brackets if you want the negative to be a part of the brackets. What this is really saying is negative and then 2 to the power of 4. So if you want to calculate that, it would be -2 And then 2 to the power of 4 would be 2 times 2 is 4 times 2 is 16. We also have another set of bracket or another exponent. I'm just going to write out the other stuff in black that doesn't have it. So we have a times 5 that I'm going to leave in black. We have a plus 16 that I'm going to leave in black. And we have a division symbol, which I'm going to leave in black. The next exponent we have is right here. That negative is part of the base. So in my calculator, I need to make sure I go bracket, -2 bracket to the power of 3. If you're doing it by hand, then you need to go -2 times -2 times -2. And you have to have a negative with the power. When you put that in your calculator, you should get -8.
-6, bud.
You did 2 plus 2 plus 2. It's 2 times 2 times 2.
Oh, shoot.
That's okay. So that's how we do exponents. You're just simplifying them to turn them into numbers. And then you do division multiplication the same way we were doing it before. So you look for any divisions. I do have a division. It's right here. If I go 16 divided by -8 in my calculator, that will turn into -2. So I now have -16 times 5 plus -2. When you have a plus -2 like that, you could continue to write it plus negative. That's fine. It's a little bit redundant though. We typically just turn plus negative into subtract. Okay, if you're adding a negative number, you're really just doing subtraction. So if you want, you can save yourself a little bit of work and just put 5 minus 2 instead of 5 plus -2. Both are right, so it's kind of your choice. If we continue on with our BEDMAS, M for multiply, we look right here. We do have multiplication. We have -16 times 5, which will turn into -80. Somebody tried that to confirm. -80, that's awesome. And then the plus sign will stay the same. And the -2 in red will stay the same. So if you look at that, we did our multiplication. -16 times 5 is -80. I left the plus symbol in there just in case people are freaking out and they're like, where to go. If you didn't keep the plus, you should have -80 minus 2, right? To each their own. If you put this part in your calculator, it's the addition of BEDMAS. -8 plus -2 would be -82. When you're putting that in your calculator, you probably have a negative button. So for your negative button, it's typically beside the decimal, like down here. That's a negative. Subtraction's on the side. So it's a little bit different. If you tried to do plus minus in your calculator, it probably doesn't work. But if you do a plus negative, it probably does work. Yep, that would be it. It's typically on the bottom of the calculator beside the decimal, not always. So if you can't find yours, just let me know.
Oh, shoot, this is trippy.
Yeah. So -82 is the last one.
Everybody do the
Okay. G.
Try to teach this, please.
No.
Yeah.
G. They're just installing a TV downstairs. It was down below us. If you look at G, this one would require you to do brackets and stuff like that. It was -82. Sorry. And I'm going to show you like the long way through it, and I'm going to show you a quick way through it. And so, if you wanted to do this properly and you were doing BEDMAS, this is a great example of brackets. We have lots of brackets here. So when you read brackets, you want to go to the smallest set of brackets you have first, which would be right here and right here. Those are the calculations you should do first. Everything else should remain the same, including the brackets, in case they had like an exponent on them or something. So when I look at those, I will have square bracket. That red number will turn into 21 minus 6 is 15.
Why are you trying to get Oh.
With a 3 times. This will turn into 5.
knock.
I know, we just need to ignore.
Oh,
and then big bracket 0. So simplify inside the brackets first so it looks like that. It's a fast way to do it.
Yeah, you should put me cheater as a name.
Next, you need to do any exponents. And we do have another set of brackets here, right? We have like the big square brackets. So we're focusing our attention inside these big square brackets first. The second thing is to do exponents. If you do your exponents, I don't know 15 times 3.
It's 15 times 3.
Has anyone done 15 times 3?
Ready?
Or sorry, 15 to the power of 3. 15 times 15 times 15.
3,375.
Thank you.
0.
It was always part of the question. Yes, you may.
It's 5,000
to the 6, and I guess it's got rid of the 6.
And the 5 to the power of 6, has anyone calculated that one for me? Dan, can you do 5 to the power of 6? 5 times 5 times 5 times 5 times 5?
15,625.
15,000.
Oh, I just said it.
625.
You're not listening.
Oh, I wasn't listening. That's why I was asking for it again.
Drake, no one heard you say it.
I heard.
All to the power of 0. If we continue on,
Fine, I'm just dead.
we have division for BEDMAS. There's no division. If we do multiplication, we should technically multiply these two things together. The number's going to be ridiculous. Right? But if we do it, let's see. Does somebody want to calculate and see what it turns out to be? Well, okay, read it. You're going to read it to me.
Alright. So it's, well, basically saying it's 52 million. 700,000.
That's how much money I have in my bank account.
34
734,000?
and 325.
That's not that bad.
That's actually not that bad. Pretty big number, but not that bad. And then we still have the big square brackets. Now that we've done everything inside the big square brackets, now we can do anything outside the big square brackets, which is this exponent 0. We learned a long time ago that any base to the power of 0 equals 1. So this entire thing
It's just one.
equals 1.
Like,
So that means when you're doing these questions, especially once you get your assignment, what you want to look for is to the power of zeros. If there's any to the exponent 0, you need to go to that power and change everything inside the brackets to just be 1. And it'll save you a lot of time. Now, looking at that question, it was good for us to do inside the brackets, so we saw BEDMAS. So it's still good to see the process. But in the future, we can just hunt out these zeros and make things much faster. Right? So look for those exponent zeros.
So for the next question, in like the first of brackets, that would all just be 0.
Good question. So for h, we have an exponent 0, right? So if you look, you have it right here. When you have an exponent 0, it changes the base and that power to be 1. That 0 has a base of only 2, which means that this turns to be 1, but nothing else. So this now becomes
1.
2 to the power of 6 times 2 to the power of 2 minus 13 times 1.
2 to the power of 6 times 2 to the
Everything else will stay the same.
minus 13 times 1.
So if you see those exponent zeros, it is kind of nice to deal with them first and kind of like cheat ahead of BEDMAS a little bit. Right? We can calculate those things ahead of everything else.
1.
This is going to be a very good BEDMAS question. So it's going to cover basically all of our bases. So the first step is to do inside the brackets. That means I need to calculate inside here and inside here before I do anything else. Like those are the first two areas I perform BEDMAS on. Then once I'm done everything inside the brackets, I basically reset BEDMAS. That's kind of how it works. So looking at this first set of brackets, if I'm looking inside of it, I now want to do exponents. I have exponent here, an exponent here, an exponent here. I need to change all of those things for the E in BEDMAS. Everything else will stay the same. 2 to the power of 6 is 2, 4, 8, 16, 32, 64 times 2 to the power of 2 is 4 minus 13 times that 1 is still there. Divide by -1 plus 2 to the power of 2 will change to be 4. Bracket 5. That's what my equation looks like after I've calculated all the exponents.
I got a question for you.
Yeah.
Do you want to go to Disneyland with me?
No, too much work. Then I do any division or multiplication that's inside the brackets, right? There's a division right now in the middle, but that's not inside the brackets, and I'm only working inside the brackets right now. So if I look inside the brackets, I have a multiplication right here, a multiplication right here, and those are the only two I should be calculating. 64 times 4 should be 256. Looking for a nod. Yeah, 256. Minus 13 times 1 should be 13. Bracket divide by bracket -1 plus that 4 is still there to the power of 5. Now I can do any additions or subtractions inside the brackets. So if I'm looking, I have a subtraction inside the brackets there, an addition inside the brackets there. That means inside this first set of brackets, I now have 243. Divide by, inside this set of brackets, I have 3.
The numbers are big.
Yeah, it should be pretty large. I now have 243 divided by 3 to the power of 5. I've only done BEDMAS for the letter B. That was everything in the brackets. Now I do BEDMAS again for everything outside the brackets. If you look, the next letter is E for exponents. I do have an exponent. That's what I need to calculate first. If you don't calculate that exponent first, you're not going to get the right answer. So this will become 243 divided by 3 to the power of 5. Has anyone done it?
243.
243?
What?
And then you can finish off with any division multiplication. We have one division multiplication. 243 divided by 243 is 1. So it all equals 1. Typically in these questions, it will come out to be a decent answer. It shouldn't be too ridiculous. So if you're getting answers that seem like astronomical, maybe just double check your work to be like, oh, something's up. Like this is way too big of an answer.
I got 34.
Yeah, so you probably did 243 divided by 3 and then to the power of 5. Yeah, which is a very, very big number. Yeah.
I have like a question about
Okay, on the one we just did?
yeah,
Which step yet?
like with the
It's good if everybody can.
like the 3 to the power of 5.
Yeah, this guy right here in green.
Oh, I just got negative 243.
You had negative 243.
Yeah.
Did you put negative 3 to the power of 5?
Yeah.
That would be why.
No, like I did 3 to the power of 5, but then at the start I did like negative 3 and then like times 3 times 3. So that's why I would have got negative.
Yeah, that's why I turned negative. Yeah. And it would change it, right? So you ended up getting -1 as your final answer.
Yeah.
Awesome. That's BEDMAS. You're going to do BEDMAS like the rest of your high school life, no matter what math you take after this. So you might as well get used to it. It's also kind of a useful skill if you ever have to do math outside of here, because BEDMAS is just like a natural math rule that we follow. What's up, Drake?
My dad's name is Michael, but he died.
That's good. And his name's Michael.
Yeah, but he died, but
I'm
I
sorry to
still
hear
have my
that.
stepdad.
That's good. All right, example 2. Michael. Hey, that's what you're saying. Okay, I was like, that's a random thing, but then it said Michael. I get it now. This is like a type of question that you're definitely gonna see. So they'll give you step by step of somebody else's work, and then they'll ask you where the mistake is. Right? They love to do those types of questions on unit tests and diplomas, PATs, final exams, that kind of stuff. It shows that you truly understand what's happening, because they might be able to maybe show their work a little different, but it's still mathematically correct. What you're looking for is to just figure out something they did that's not mathematically correct. Maybe not what you would have done, but it has to be not proper. The way I like to do it, yeah, so like they might have done steps different than we would do steps, but if they still followed math rules, that's okay. The way I like to do it is I go from step to step and I try to identify what's changed. So they started with this, they turned it into this. And I try my absolute best to figure out what's changed. Looking at this whole section has not changed. Right? They still have the negative 4 times 3 to the power 2. That's stayed unchanged. What has changed is this that I'm highlighting in green. They've changed this. They went from 3 plus 5 squared to 8 squared. If I was doing this question, what I would have done is I would have added 3 plus 5 to get 8, and that would have been proper because that's inside the brackets, which is what BEDMAS says to do. That means step 1 is done properly. Then try to figure out what's changed from step 1 to step 2. Again, this has remained the same. And again, this has changed. Instead of putting 8 squared, they got 64. If I was doing BEDMAS, I would have calculated the exponents next, which is 8 squared. If I put in my calculator, 8 squared is 64. That means that's a correct step. Now looking, the next thing that they've done, they've left this times 3 squared. That looks good. But now they've somehow come out with 60. And if I were doing this question, my next step would have been to do the exponents on 3 squared. However, they didn't do that. They somehow got 60. Darian, how do you think they got 60?
They got 60 because instead of
drilling holes.
going and doing Anyways, so instead of doing the exponent of 3, they just subtracted 4 and they skipped what they did instead.
Yeah, so they went ahead and started doing the subtraction. They did this 64 minus 4, which breaks our BEDMAS rule. So if this was a question on a test and said, where's the first mistake? That's the first mistake. The first error was in step 3.
I thought
That
the
sounds
first error was
pretty
in
We're almost done, guys. Our goal now is to correct their mistake. So I'm going to go to step 3. I'm going to go to step 3. And I'm going to start putting it in correct, starting at step 3. Because step 2 is still good. To go from step 2 to step 3, they should have done the exponents next, which is right there. Therefore, I should add 64 minus 4 times 9. Because 3 squared is 9.
Oh. Geez, 3.
Then I would have done multiplication to get 64 minus 36. And then my last step would have been to do the subtraction, which would have ended up being 28. I'm really bad at subtraction. And that would have been my correct solution. Those are popular types of questions, so it's probably something you're going to see again. If not this year, for sure next year, because I know what the 10C stuff looks like.
Thanks, Walter.
For sure. Last one. I'll go through a little quicker so you guys can have some time to practice. If you're looking at this, again, they're saying, what's the mistake? So I'm going to look at their step 1, and I'm going to figure out how they got from this to this. I try to identify what stayed the same and what changed. If I'm looking, it looks like they've started inside the brackets. So in red stayed the same. All of this stayed the same. This stayed the same. This appears to have changed. And this has definitely changed. I need to see if they've done the changes right. Looking at the stuff in the blue, they have 3 times 4 squared turned into 12 squared. I know that exponents should have come first. They haven't done any exponents yet because the squared is still there. So their mistake was that they did 3 times 4 to get 12 when they should have done the exponents first, which would have been 4 squared is 16. So you have to follow exponents before you could do any multiplication. That's their first error. If I was doing this question all over again, though, I would have noticed this beautiful 0. That 0 means that everything inside the brackets becomes 1. And I now have negative 1 divided by, and if I do this exponent, that would be negative 8. That one rule can save you a lot. Now I just have to do negative 1 divided by negative 8, and my answer is 1 over 8. If you wrote that as a decimal, it's 0.125, he says, with 0 confidence. 1 divided by 8? Yeah, I'm going to go with that. Now I'm now confident.
Yep.
Awesome.
Excuse me.